Hello my friends and business partners from around the world. Welcome to my channel. My name is Rafael. I'm an electrical engineer, book writer, business English coach, professional translator, and bilingual teacher of mathematics and physics here in Brazil. And on this video, I'm going to talk about signal amplification with you guys. And to do this, I brought this exercise. In this exercise, we want to express the gains of the amplifier in decibels, okay? Do you know how to express gain in decibels? If you want to find out, continue watching this video. Okay, and we want to calculate the voltage gain, the current gain, the power gain, the power drum from the DC supplies, the power dissipated within the component, and the efficiency of the component, the efficiency of the amplifier. See this image here, okay? This is the general representation of an amplifier, and we want to amplify this signal. We are going to assume that this signal here that we wish to amplify is very weak, okay? It can be the output of a sensor, for example. We need to amplify the signal in order to further process it. And to do this, we are using two DC power supplies, V1 and V2. With the power obtained from these power supplies, we are going to amplify the signal. Okay? So, this is going to be amplified in order to be further processed. Alright, so I am going to read the exercise, and if you want to know how to amplify signals, please let's do it. Pay attention and you're going to understand everything. Okay, calculating amplifier gains in decibels and its efficiency. Consider an amplifier operating from 10 volts, positive 10 volts and negative 10 volts. So this is going to be positive 10 volts and this is going to be negative 10 volts. DC power supplies, it's fed with a sinusoidal voltage of 1 volt peak. This is the input to the amplifier. This is the signal that we wish to amplify. 1 times the cosine Wt plus 5 volts. And delivers a sinusoidal voltage output of 9 volts peak. Okay, so after amplification, the input becomes 9 volts times cosine Wt plus 5 volts. Okay, and it delivers this voltage to this component here. We are going to call it the load resistor. The amplifier draws a current of 9.5 milliamperes from each. I1 and I2 is 9.5 milliamperes from each of its 2 power supplies. The input current of the amplifier is found to be sinusoidal with 0.1 times the cosine Wt plus theta amperes. From the voltage gain, so the exercise wants us to calculate the voltage gain, the current gain, the power drum from the DC supplies, the power dissipated within the component, within the amplifier, and the amplifier efficiency. Okay, friends, let's do it. Let's solve the exercise, alright? First of all, before I erase this, I am going to talk about the expressions here. How do we convert the voltage gain into decibels? We simply multiply it. We take the logarithm of the voltage gain and we multiply it by 20. The same thing with the current gain. We take the logarithm of this and multiply by 20. But when we talk about the power gain, we take the logarithm of it, but we don't multiply by 20, we multiply by 10 only, alright? So this is how we express amplifier gains in decibels. Okay, my friends, now that I have read the statement of the exercise, and now that we know the expressions to convert the gains into decibels, we are going to calculate everything, okay? Now, I want to calculate the voltage gain, AV. AV is going to be equal to V0 divided by VI, alright? The output voltage divided by the input voltage. The output voltage peak is 9 volts and the input voltage peak is 1 volt. Then we know that this is 9 volts per volt, okay? This is the gain of the amplifier. This is the voltage gain, 9 volts per volts, okay? And now how do we express this in decibels? The voltage gain in decibels is going to be equal to 20 times the logarithm of 9. Alright? Are you guys understanding what I'm saying? Okay, do you understand that? And this, after we use a calculator, I have already done that. Okay, you can check if I made a mistake. After we do this, we find the value of 19.1 decibels. 19.1 decibels. This is the voltage gain expressed in decibels. Okay, friends? Are you guys understanding everything that I'm saying? If I am doing it fast, please pause the video and then you are going to understand it better, alright? Okay, now let's calculate the current gain. The current gain is going to be AI is going to be equal to I0 over II, okay? So this is the output current and this is the input current. We don't yet have the output current. We need to do something to find it, okay? The output current here is going to be equal to this voltage here. What is this voltage? This voltage is V0, okay? The voltage that is already amplified, the amplified version of VI, and then the load here. I think I forgot to mention the load here is 1 kilo ohms, okay? And we already know that V0 is 9, then we simply put 9 volts here. 9 volts here, okay? So the output current is going to be the division between the output voltage and the load resistance. And then this is 9 milliamperes, okay? Do you guys agree with me? Do you guys agree with me? So here the current gain is going to be equal to 9 milliamperes, and we are going to divide it by the current that was given to us. Okay, here I made a mistake here, sorry. This is in milliamperes. Okay, so it's then gonna be equal to 0.1 milliamperes, and then we find that this is 90 amperes per amperes. Okay, amperes per amperes. Okay, so this is the gain of the amplifier, the current gain of the amplifier. Alright, my friends, now let's express this in decibels. Okay, AI in decibels is going to be equal to 20 times the logarithm of 90. Okay, and this, according to my calculation here, I already calculated it, and this is 39.1 decibels. Okay, friends, are you guys understanding everything? All right. It is easy. It is easy. Let's calculate other things. Let's calculate other things, okay? we need to calculate the power gain now. The power gain will be simply the product, okay? The power gain, AP, the power gain is simply the product between the voltage gain and the current gain, but we can calculate it in a different way. How can we calculate the power gain? We can calculate the power gain by taking the power, dividing the power that is fed to the load by the power that enters the device. Okay? The power that enters the device. Alright, but how can we calculate this? Okay? The power that enters the device, the power delivered to the load, the power delivered to the load is going to be equal to the voltage at the load divided by the square root of 2. Okay, because when calculating power, we have to deal with RMS values and not peak values, okay? And then IL is the current that flows in the load, also divided by the square root of 2. And then the same thing here, I'm going to use VI divided by the square root of 2 and I divided by the square root of 2, okay? Are you guys understand what I'm saying? The square root here is because I am dealing with root mean square values, not peak values, okay? And then we find here that the power gain here already calculated, it's 810 watts per watt, okay? 810 watts per watt. Alright, and now we want to express the power gain in decibels. It's going to be 10 times the logarithm of 810. And we find that the power gain in decibels is 29.1 decibels. Very easy, isn't it? Are you guys following? Are you guys understanding everything I'm saying? If you guys are understanding, then it is awesome. It is very good. Okay, so we have other things here to calculate. I'm gonna finish the video by calculating the other parameters that we wish to calculate. Okay, my friends? Let's do it. Let's do it. Now I want to calculate the power DC, the power that comes from these power supplies here, these DC power supplies here. When we deal with DC values, we don't need to specify which is the peak and which is the root mean square value, because for DC values, the root mean square value and the peak value are the same, okay? For sinusoids, they are not, but for DC values, they are the same. So it's going to be equal to V1 times I1 plus V2 times I2, okay? And then, since this is together, since this product is equal to this product, we simply multiply this or this by 2, okay? And then ultimately, I'm gonna have that this is 10 and this is 10. This is 9.5 milliamperes. This is 9.5 milliamperes. Okay, so it is gonna be 10 volts times 9.5 milliamperes, and then you simply multiply by 2, and you are going to find out that the power delivered from the DC sources will be equal to 190 milliwatts, okay? 190 milliwatts. Very easy, isn't it? Very easy, my friends. Very, very, very easy. Now that we know everything, okay, we can calculate the amount of power that got dissipated inside of the device. Alright? To do this, we have to balance the powers that enter and that go out of the device. Okay, so the power that enters plus the power delivered from the DC sources will be equal to the power dissipated plus the output power. Okay, this is what gets in and this is what gets out. All right, do you understand what I'm saying? So P dissipated will therefore be equal to, we have already calculated this, we have already calculated this, we have already calculated this. Then we can simply plug in the values and find that the power dissipated is 149.55 milliwatts. 149.55 milliwatts. My friends, this was the power dissipated by the component, by the device. Okay, after calculating this, the only thing for us to still calculate, the only thing left off was the efficiency. The efficiency is going to be equal to the power out over the power in, the power out and the power divided by the power in times 100%. Okay, the power out, we calculated it using, okay, I don't remember. You simply go to the beginning of the video and then you're gonna see how we calculated the power out. The power out is 40.5 milliwatts divided by the power DC here, DC, it's DC, the DC power, we calculated to be 190 milliwatts, okay, times 100%, and then the efficiency of the device, we find it to be around 21.3, okay, 21.3%. All right, my friends, we can't have the denominator bigger than the denominator. Then the efficiency of the device would be more than 1, and that's impossible, okay? So the efficiency has to be less than 100%. My friends, this was the video that I wanted to make. I hope you guys learned something from it. I hope you guys liked it. And if you liked it, give a thumbs up, okay? Hit the like button for me, and then you're gonna help me make other videos. And if you wanna contact me, if you wanna talk to me, I'm gonna leave my number in the description of the video, and then you can simply drop me a message on my WhatsApp. All right, my friends, thank you, goodbye.